Okay, well, welcome back. It's third week Monday. Time is progressing right along, and you guys have your first quiz tomorrow in section. Make sure you guys get to a section on time. It will be. Let me get your attention, guys. It'll start at the beginning of section. You'll have half an hour to complete the quiz. It should. I think it's straightforward, but of course I would think that. And so anyway, you'll have that in section. It covers basically everything, what we've covered so far, and I'm going to cover one more topic on box plots, the final kind of graphic display for numeric data that we'll cover. That will also be on the quiz. And then today I'm going to start into chapter 4, which is describing relationships between two variables, scatter plots, and all of that. Chapter 4 will not be on the quiz. So the quiz will cover chapters 1 through 3, which includes today's first topic, box plots. Okay? And that will be in section. Please make sure you attend your assigned section. Okay, I know some of you guys wanted to switch sections, and I tried to facilitate a little bit of that online, and I think some of you guys found pairs successfully and switched, and others there are still just unanswered forum posts, but I guess that's that. So, okay, so let's talk box plots. So box plots are, it's just another numeric display, or display for numeric data. And the advantage of box plots is that they really boil down the data into just a few key points, and so they're very useful for making quick comparisons. They don't reveal that much detail, okay, but sometimes that's what you want. You want to avoid the detail and just have a quick summary, okay? So box plots, okay, show, less detail in general, but just the key bits of info. Okay, and so the key bits of info would be kind of the min, the max, Q1, Q3, I should say, and the median. Okay, median, min, max, Q1, Q3, and outliers. Okay, and they all and they appear. And so your general box plot will look something like this. Okay, you have a rectangle with a line somewhere like this. And you have lines extending from there. And then you might have something like this, and perhaps as well down over here. Okay. And so let me kind of just label these pieces. All right. So the box is defined by where Q1, the median, and Q3 are. Okay. Data out here, these are outliers. This would also be an outlier. Okay. The width of the box. What is the width of the box? The width of the box is the IQR, right? IQR is Q3 minus Q1, so therefore the width of the box, okay, is that. This here is the maximum because it's the highest value over here. This would also be the minimum. Okay, so then what are these things? These things are called whiskers. This is a whisker. And this goes to the largest point that is not an outlier. That is not an outlier. Okay. And this over here, also a whisker. And this is the smallest point, not an outlier. Now, if you don't have any outliers, then this could be the minimum. But if you do have outliers, then, and somebody asks, what is the minimum of the data, then you have to say the outlier is the minimum or the outlier is the maximum, okay? But if you don't have outliers, then the whisker goes to the maximum, okay? So if you have no outliers. Okay. All right, so how do we decide what's an outlier and what's not an outlier, okay? Well, as far as the box plot goes, the box plot sets up these invisible boundaries that don't appear as part of the graph, but are used in the calculations for drawing the box plot, okay? So as far as the box plot, what is an outlier? And there are, this I should say, which applies to box plots. Okay, because the discussion of what is an outlier has been long discussed by many people. Okay, so anyway, we have something called an upper fence. These are, I'm going to just say, we have invisible boundaries that separate outliers from the rest. Okay, so we have the upper fence, and the upper fence is equal to Q3 plus 1.5 times the IQR. And then we have the lower fence, which is Q1 minus 1.5 times the IQR. Okay, so let me just illustrate this a little bit. So here's a rectangle. Okay, so this distance here, from here to here, this is my IQR. And we've already established that this is Q1 and this is Q3. So if I take my IQR, it's actually just this part, okay? So if I take this and I go out 1 and then half of this, so what's that? Maybe like right there, okay? So this is 1.5 times the IQR. This is where I would put my invisible boundary here, okay? So if we have data beyond here, data larger than this spot, these would be considered outliers. And these are not outliers. And so the whisker goes to the largest point that's not considered an outlier. It doesn't necessarily go to the fence. Okay, so the whisker goes to largest point, not an outlier. That is not an outlier. It does not necessarily go to the fence. Okay, and then if you have anything that's larger than the fence, these are considered outliers. Okay, whatever. I'm just arbitrarily drawing some dots there. And then you apply the same thinking down on the lower end. Okay, we say if this is 1.5 times the IQR, I go down this distance below. Okay, and then over here, down over here, this is my lower fence. Okay. And so, perhaps you don't have very much data down here. Maybe it goes down to here. Okay, I don't know, something like that. So here, that kind of sets this up. If we looked at this, can we talk about the shape of our data? Is it symmetric, left skewed, right skewed? Can we not tell from this? Okay, I would say it is right skewed. This data is right skewed, okay? Because as far as the data goes, this is our minimum, right? And then this is our max out here. Okay, so the data is right skewed. Now, how do I know that? Okay, right skewed means you have certain values that are much higher than the rest of the data, right? So you have extreme values on the right side, extreme values on the right, but not on the left. Another indication that this would be right skewed is that the right whisker is longer than the left whisker. Okay, so right skewed would also mean the right whisker, right side whisker, is longer than the left whisker. Can you tell if this is unimodal, bimodal, or whatnot? No, okay? The box plot will not reveal whether it's unimodal or bimodal, okay? So I don't know if I can fit that on here. Okay, was there a question there? Yes.
So the median line doesn't have to be in the middle of the...
The median line does not necessarily have to be in the middle of Q1 and Q3, okay?
So what does it imply if it's not?
The median, if the median is closer to one side than the other, okay, all it just means is that, we can kind of split our data into 4 zones, and we can say, 25% is below Q1, 25% is between Q1 and the median, 25% is between the median and Q3, and 25% is larger than Q3. That's all that it really says, okay? Basically, it just means there's approximately the same number of people over here as there are over here, okay? So maybe, this area might be a little bit, quote, more crowded, but other than that, that's all it's really saying. As far as, the skew, I would say depends more on the whisker than the box itself, okay? Because the skew is always talking about the extremes, and not so much what's in the middle. All right, and so, again, with box plots, use the right tool for what you want to do, right? So the advantage of box plots, the strength of box plots, is that it just provides a quick glance, all right? So box plot strengths are for making comparisons between different groups. Because there's, just less detail to kind of clutter your picture. All right, so here we can have this, and we can have to make sure the whisker doesn't go past 1.5 times this. I'm trying to eyeball this, but I can't really tell. Okay. All right, so here we go. All right, so we'll say this is what we have. Okay, so this will be group 1, and this will be group 2. Okay, so what if I said on average, or okay, first question, we'll keep this simple. Which group has a larger spread? This is too easy. All right, and you would all say group 2, right? Because the width of the box is wider, right? Width of box is greater. So larger IQR. Okay, we can, I don't know, but both groups have the same median, okay, right? And, right here, between here and here, we have 25% of the data. And between right there and there, there's also 25%, okay? Also here, 25% over here, 25% over here, 25% down here, and 25% over here, okay? 25% and also 25%, okay? I would say both of these are right skewed, okay? Both groups have the same median, both are right skewed. Okay, and I don't know, just kind of looking at them, we can see as far as, Q3 goes, Q3 of group 2 is, almost the max of group 1, okay? Okay, except group 1 does have some outliers that are higher, okay? So you might see, box plots, kind of multiple box plots next to each other, and you can use that to make comparisons between them. Okay. Is that good with everybody? All right, let's, so that wraps up chapter 3. Now we'll start getting into chapter 4. Chapter 4 still falls under the topic of descriptive statistics, but now we are describing the relationship between two numeric variables. Okay, and so let's say we're looking at a certain species of snake, okay? So let's say we okay, and so and we will record the weight of each snake and the length of the snake, okay? So we will look at, I don't know, several specimens. Okay, and we will record the weight and the length of each snake. And so, this is me drawing a picture of a snake. All right, there we go. So there's one snake, and here's another snake. All right, okay. And then, and for each snake, we'll just, I'll say the length will be X, and the weight will be Y. Okay, and so here I'm just making up some snakes. Length and weight. Okay, I have no idea. Let's say we have a 12-inch snake, 14-inch snake, I don't know, 10-inch and 8-inch. And now I'm just making up some numbers here. Are these ounces, I guess? Okay, so this is what we have. Okay, and overall, our primary question is there a relationship between the length of a snake and its weight? Okay. And, just thinking about this, right? If we just think about what snakes look like and we look at, snake A versus snake B, which one do you think is going to weigh more? Snake A, right? This is, all of these questions I've been asking are too easy. And so, we would say, yeah, we would expect to see some kind of relationship where longer snakes will weigh more, okay, right? So, yes, we expect longer snakes to weigh more than shorter snakes, okay? Okay, and we can create this is, we would call a scatter plot, okay? So a scatter plot is our first visual tool, and all we do is we just put one of these variables along the x-axis. So 7, we'll say this is 8, 9, 10, 11, 12, 13, 14, okay, 15. And then over here, I'll go 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, what did I say? 8, 10, 12, 13. Okay, and then I would just plot each of these. So 12 inches and 14, I don't know. So we get a dot right there, 14 and 16, so that goes right there. 10 and 10, we get a dot right there, and then 8 and 9. So a dot right there. So this is what our data looks like. And indeed, it does appear that longer snakes, so this is X, our length, and Y, our weight, it appears there's a trend, okay? This is kind of our most basic thing, so let's just, we'll start describing this, okay? All right, so this is kind of the general idea, and all of our data and our examples will not be easy, right? Because I mean, as far as snakes go, how we would expect a very strong relationship between the length and its weight. Okay. All right. So when we describe a relationship between two numeric variables, okay. So when we describe a relationship, there are three things to mention. Okay, so number one is the direction or the trend of the relationship. And the direction or trend, we can generally say positive, negative, or neither. Neither positive nor negative. I guess you can use the same terms for a relationship between people. It's a positive or negative relationship, okay? Or neither. Strength of the relationship is the another aspect that we want to talk about. And for that, we would say strong or weak or something in between, moderate. And then lastly, we have the shape of the relationship. And we will have linear. As far as this class goes, we will have linear versus nonlinear, okay? And in our class, we will only deal with linear relationships, okay? Okay, so let me see. Let's talk about shape of the relationship first, okay? So whenever we're describing a relationship, the first thing we should do is create a scatter plot, okay? So, whenever you have two numeric variables and you are trying to, and you want to describe them, or you want to investigate the relationship, always make a scatter plot. And so, linear can be used for anything where the data seems to fit. So this would be highly linear, okay? So it seems like the overall trend looks kind of like a straight line, okay? So I could throw a line through this, and that looks pretty reasonable, okay? So the overall trend looks like a straight line, okay? Okay, and then anything that's not a straight line, okay, or I mean, these are just very obvious things, but you probably have a little bit more scatter or something like this. Okay, these we would just say these are nonlinear. Okay, so let's think about this. Okay, so here well, this will be our first clicker question. Okay, so think of people's. So here's our the variables. The population will be people in the general population. Okay. So people in the general population of the USA, okay? And we will say X, the X variable will be the person's age, and the Y variable will be the person's height, okay? All right, and so, do you think the relationship is linear or nonlinear? Okay, so turn it on. When you turn it on, it should say like stats 10 or something, okay? So you can go ahead and talk to your neighbor about whether you think the relationship between age and height in the general population of the USA, so this is including as many people in the general population of the USA, is the relationship linear or nonlinear? Okay, I'm gonna. Okay, we'll say 10 seconds. 10 seconds. Get your clicks in. All right, let's take a look. Okay. Most of you said nonlinear. Some of you said linear, and the answer is nonlinear. So let's just kind of plot what this might look like. Okay, so in the general population, we'll start at 0, and we'll say it goes to 100 or something. Okay, as far as age goes. I don't know. Okay, so 50 is somewhere around there. 10, 20, 30, 40, 60, 70, 80. Okay. And I don't know how tall people go, but generally, what's going to happen is, in the beginning, we're going to see a lot of kind of going up as people age from around 0 to 20-ish, something around there. People keep growing taller and taller and taller. I mean, some people stop growing when they're around 13 or something, and some people are still growing at like 21 or 22. But then right around there, it kind of stays steady, right? Okay. And perhaps once you start hitting 60 or 70, then there's a slight decline in height, just as your the discs in your back start to get compressed and all of this, and bone density is reduced, and I don't know, something like this. Okay, so overall, this is not the general trend cannot be described by a single straight line. Okay, so the overall trend does not fit a straight line. Okay, so there's probably a couple areas, maybe if we looked only at people 0 to 18, we might see a fairly linear trend. Okay, so there could be linear, could be linear for data in ages 0 to 18ish, something around there. Okay, and then you might have there might be another linear trend from, I don't know, something. Okay, you might say this is also linear over here, but I would say it's probably less so. Okay, but overall the relationship would not be linear. Okay. Okay, now let's talk about the direction of a relationship. Something's going on here. Okay, so as far as the direction goes, we have positive direction. Positive direction, this means large values of x tend to go with large values of y. Okay, and small x tends to go with small y. All right, so if we draw a picture, it would look something like this. So if we look down here at small x, we see that small x goes in general with small y, and then large x goes with large y. Okay, so values up here, you're going to have values like that. So example of that was, snake length and snake weight. We expect large x to go with large y. Okay. The negative direction is just the opposite. I'm just going to write large x goes with small y. And these are in general trends, okay? Of course, you can have some exceptions. Small x goes with large y. So it's large x, small x. So if we look at this, the small x tends to be associated with the large y, large x goes with small y. Okay, so this would be the negative direction there. So an example of this could be, let's say you're looking at used car market, okay, used car prices. If we say x is the mileage on the car, and y is the sale price. Okay, and I know that there are many factors that go into determining the price of a vehicle, but in general, vehicles with high mileage will sell less than vehicles with low mileage. Okay, so vehicles with high mileage will have a low sale price. Vehicles with low mileage will have a higher sale price in general. And so that would be a negative direction there. Okay, and then we have neither positive nor negative. Okay. And all of these terms about positive and negative and all of that, that can apply to both linear and nonlinear relationships. So here, This is neither positive nor negative. Okay, it's a flat line. Okay, x and y. So this would be neither positive nor negative. Okay. So I don't know, maybe this could be y could be, I don't know, x could be how much money you have. We'll say how much money in the bank. And then y could be, I don't know, shoe size. Okay. I don't know, who knows? Maybe if there's a trend there, I'm not aware of it, okay? We would not expect to see any kind of relationship there, all right? Or, you know, even further, you know, if you just have a massive cloud of points, something like this, okay? Also, okay? This could be, I don't know, whatever two numeric things that aren't really related, okay? But also, neither positive nor negative would be okay, something like this. Okay, this could be time after, like after liftoff, and this could be, you know, height of your rocket, something like that. Something could be something like that. So this would be neither positive nor negative. However, if your rocket goes up and then, I don't know, explodes right there, and now you have no more data, okay? This overall would have a positive relationship, okay? So if it gets truncated here, if this is your entire data, okay? If this is the entire data, okay, we would classify this as overall positive in general, okay? And if we didn't know the context of the data, we cannot assume that it's going to keep going like this, because you know what happens in the future is that it could go like that, it could go like this, who knows, it could even go back up. We have no idea. We can't assume what the future of the data looks like if we don't have any context. If we're talking about a rocket, then we understand physics and we can say, okay, well, it's going to keep falling down. But if this is like, I don't know, the stock price of something, okay, we have no idea what's going to happen in the future, okay? We can say, oh, well, this is right when, I don't know, the CEO was caught in a scandal, so it goes down. But then something happens here, and who knows? Maybe everybody else on the board gets in a scandal, it shoots down, right? And they go, oh, no, this was not a big deal. They just released super product 9, and now the stock's gonna rocket up, okay? Who knows? Who knows? We are running out of time, and I've only asked you one question so far. Okay, let's all right, I'll just give you a freebie, okay? I just feel like throwing in another question. Okay, so just click A, everybody. All right, so everybody should click A, and then we'll give everybody a point here, and then we'll wrap up today's. Okay, is that everybody? Everybody's good? Okay, and we'll talk about the strength of the relationship on Wednesday. We'll see you guys in a couple days. Yes. Wait. Who's? Somebody clicked B. Make sure you click A. All right. Okay.